Hello, everyone. Today we're going to be learning Target 5, which is the Pythagorean identity. So we're going to be talking about the Pythagorean identity with trigonometry. So let's get started. So let's first review what the Pythagorean theorem is. I'm sure you all remember because it's taught to you in a couple different levels of math and also kind of a big deal when you're taught it there. So I'm sure everyone remembers that the Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs of a right triangle and c is the hypotenuse. So over here on this right triangle that we drew, I drew it on a circle. I drew it on the unit circle, actually. So on the unit circle, the hypotenuse is always 1. And you can see that there are these coordinates over here. So the coordinates of that point on the circle, it's not any particular spot. It's just a point on the circle. It's not one of our 30, 60, 90, or 45, 45, 90 spots. It's just a point, A comma B. And with that point being A comma B, that means that this side of the right triangle is A, and this side of the right triangle would be B. You went over and up. So if we apply the Pythagorean theorem to this triangle, we would have a squared plus b squared equals 1 because the hypotenuse is 1. So it's applying the Pythagorean theorem and creating this Pythagorean identity. Okay, so this is an identity because it's equal to 1. So now we're going to do this same process, but we're going to think of my angle being or my triangle, let's say, being a 30, 60, 90 right triangle. So let me actually erase a little bit of this here and move the green identity part out of the way. So if this is a 30, 60, 90 right triangle, we'll call this a 30, and this is the 60. That means this side over here is a half, and this side down here is √3/2. So think about our coordinates that you're supposed to have remembered just from our quiz, that you would have those were the coordinates over √3/2, and up a half. So to the right, √3/2, up a half. So now if I apply this identity formula to this triangle over here, it would look like this. So I would have square root of 3/2 squared plus 1/2 squared equals 1. So now I can go ahead and square both of those parts. So square root of 3/2 squared becomes 3 in the numerator and 4 in the denominator. And then 1/2 squared is 1/4. And notice that 3/4 plus 1/4 is 4/4, which equals 1. So the reason that this is important is because you can then use the Pythagorean identity to help you solve missing sides of a triangle that are not angles that we know. So if they're not 30, 60, 90, or 45, 45, 90, you can still use this identity to help you find the missing sides. So let me show you what we mean. So here's our first problem, and we have this information about cosine, and it's in quadrant 1, but the cosine isn't an angle that we know. It's just 7/25 is the ratio. It doesn't really tell me anything. So what we're going to do is just kind of draw a random picture of a triangle in quadrant 1 where the cosine is 7/25. So remember, cosine is the x coordinate of a right triangle. So 7/25 would be this side. 1 is going to be the hypotenuse because this triangle is on the unit circle, and the angle is down here, always attached to the origin. So if we want to find sine of this triangle, or of this angle, we would want to find this side of the triangle because sine is the y value. So we're going to apply that Pythagorean identity to this situation and I'm just going to give a variable name to that y value. I'll call it y or call it b, whatever you like. Okay, and then this becomes 7 over 25 squared plus, we don't know b, so plus b squared equals 1. So yes, then we have to be able to do a little bit of squaring or multiplying and stuff, either in our heads or in our calculator. So 7 over 25 squared is 49 over 625 plus b squared. And then I'm going to turn 1 into 625 over 625, so I have a common denominator that I can subtract. So now I need to know what 625 minus 49 is, which I don't know that one off the top of my head, so I'm going to do it over to the side. 625 minus 49 is 576. Sorry, I don't know why I was pausing there. So I get 576 over 625. And I am pretty sure that when I take the square root of both of these, 625 square root is 25. We already knew that because that was what we got when we squared it over here. And the square root of 576, I believe, is 24. So our missing side over here is 24 over 25. So that means that sine of whatever this angle is, we don't know what it is. We don't really care what it is. We just want to know what the sine of it is. And sine of this side over here will be 24 over 25. Okay, remember you can always pause the video if you need to take some more notes. We're going to do another one. So then this one is not going to be quite as nice because the numbers are not going to work out to be whole numbers. We're going to have radicals, but that's okay. So this situation has the theta in quadrant 3. So when I draw the triangle that I'm working with, I'm going to draw the triangle in quadrant 3. So just draw it like this. So here's our theta like this. And it says that sine of theta is negative 1/3. And the negative makes sense because we're in quadrant 3 and the y value here is in quadrant 3, going down, so it's negative. Hypotenuse is still 1 because again, we're on the unit circle, always on the unit circle. And I am missing this side over here. So call it A, call it B, call it X, whatever you'd like, whatever variable works for you. So there's my triangle. I'm really just doing the Pythagorean theorem, but I'm always using 1 as the hypotenuse. So I have a squared plus negative 1/3 squared equals 1. So then I get a squared plus 1/9 equals 1. So a squared equals, I'm going to turn my 1 into 9/9. And I'm going to take the square root of, sorry, not the square root yet. I'm going to subtract 1/9 from 9/9. I get 8/9. And now I'm going to take the square root of both sides. So I get a squared. Square root is a. And we're just going to leave the square root of 8 as the square root of 8 because it's not a perfect square. And I'm going to take the square root of 9 and I get 3. Okay, well, I just got a positive answer because I didn't take into account if the square root has 2 answers. So there's technically 2 answers, positive or negative. However, I only want one answer because there's only one side to this triangle, but it's not determined upon if the answer should be positive or negative just here. It's actually determined from this picture, understanding that you're in quadrant 3, and in quadrant 3, the x goes to the left, so x values are negative. So the answer you want to choose is negative square root of 8 over 3. Okay, so your homework is to finish the rest of the worksheet. Make sure you have that done so that tomorrow we can go over it